In this video, I'm going to be going over lesson 4, which is about interpreting solutions. All right, let's get right into it. So our first question says that a rideshare company charges $5.25 per ride for up to 4 passengers. It also charges an additional 50 cents per mile. Becca takes a ride from the airport and it costs $9. She wants to figure out how many miles from her house is the airport. Which pieces of information can Becca use to determine how far her house is from the airport? Select all that apply. Okay, so this rideshare company, it's kind of like an Uber. So Becca here is at the airport and she wants to take an Uber or like a Lyft back to her house. Okay, so right here it tells me at the top that this rideshare company charges $5.25 per ride. Okay, so regardless of how many miles you're driving, they're going to charge you $5.25 is like a base fee. And that's up to 4 passengers. So up to 4 people can fit in this car. And then after that, it charges an additional 50 cents per mile. Okay. And I know that Becca paid a total of $9. So let's read through our answer choices here. This first one says that Becca's ride home from the airport costs $9. Well, this one's true, right? Because right here it says that she paid a total of $9. B says that the rideshare company charges 50 cents per mile. This one is also true. It says right here that the rideshare company does charge 50 cents per mile. C says that the rides can hold up to 4 passengers. That is also true. Rides can hold up to 4 passengers. It's probably a standard car that can fit 5. So you have your driver and then the 4 passengers. And the last one says that the rideshare company charges $5.25 per ride. Let's see. So I double checked really quick. This one down here, the rideshare company charges $5.25 per ride is correct. However, in your course, this one here, C, that says rides can hold up to 4 passengers, this one is not marked correct in your book or in your workbook. However, I think that might be an error just because it does say that they can hold up to 4 passengers. So technically this information here is true, but in our workbook, this is not marked as a correct answer. So for this one, we want to have A, B, and D be correct. Or it might be in a different order in your workbook, but those are the 3 that you'd want to select. So don't pick the one that says rides can hold up to 4 passengers. Our next question says that Rachel is running a 5K race with 200 participants. She knows she can complete 1 kilometer in 7.5 minutes, and she plans that pace for the whole race. However, she wants to give herself some extra time to take a water break at the halfway point between each kilometer mark. So each kilometer she runs, she's going to take a little water break halfway through that kilometer. Her goal is to complete the race in 38.75 minutes, and she needs to figure out how much time she can take for each water break. It says, what can Rachel assume to be true when calculating her time for each water break? Okay, so let's read through these answer choices first after reading the question. A says that the other participants are faster than her. Well, that's not necessarily true. Nothing really tells us how fast other participants are going to be. So I'm going to say that one's not correct. B says that her speed will be faster because she's competing. That could be true. However, there's nothing here really says how fast she's going to be going. She just wants to complete her 5K race. So I'm going to say that one's also not true. C says that the planned route for the race is exactly 5 kilometers. So the entire route that she's running a 5 kilometer race. So the route has to be exactly 5 kilometers. So for this one, Rachel, what we know is that the planned route is going to be exactly 5 kilometers. Next question. So notice that here we have the same prompt that we did with our first question with Becca and taking her ride from the airport to her house. So she's still paying that $5.25 per ride regardless of how far she's going. And then that's going to be up to 4 people, and they're going to charge 50 cents per mile, and it costs her a total of $9. Here, with this question, we're going to start answering that last question that we didn't quite get to last time, where it says she wants to figure out how many miles from her house is the airport. And what does Becca need to do to figure this out? Well, to figure out how many miles her house is from the airport, we got to kind of do a little bit of backwards thinking. So let's start with how much she paid total. I know that Becca paid a total of $9 for her entire ride. Okay, so she paid a total of $9. And this $5.25 up here, that's a one-time fee that she would have to pay, or any customer would have to pay, regardless of how many miles they're driving. Okay, so that $5.25 I'm going to subtract from this $9. Okay, and when I am subtracting those, that's going to give me how much money I'm paying for in miles. Okay, this right here, so this is my total. This right here, this is the one-time fee. Okay, this is like you're using my service, so I have to charge you this, and then anything on top of that is going to be 50 cents per mile. Okay, once we subtract these, we should get, let's see, do some mental math here. We should get $3.75. Okay, so $3.75 is how much money Becca is paying in miles. And I know that it is 50 cents per mile. Okay, so since it's 50 cents per mile, we would take this $3.75 here and we are going to divide it by 50 cents. And when we divide this by 50 cents, that is going to tell us the number of miles that Becca had to take. So reading through these answer choices, we subtract $5.25 from 9, then we divide that number by 50 cents. All right, so here we have Rachel again, and she's still running that race. And her goal is to complete the race in 38.75 minutes. We know she's taking those water breaks, and she knows that she can complete 1 kilometer in 7.5 minutes. This is very important information, okay? So we have this table, and this table is how long it takes her to actually run each kilometer. So if I look here, when she runs 1 kilometer, it takes her 7.75 minutes. So the question is asking us, how many minutes does Rachel take per kilometer for a water break? Okay, well, I know that she can run 1 kilometer in 7.5 minutes without taking a water break, right? But when I look at this table here, this is what she actually did in her race. So when she completed her race, it took her 7.75 minutes to do that 1 kilometer. So what we need to do is figure out the difference between her actual run time, 7.75, in the race, and what she could do without taking a water break, the 7.5. So when we are finding the difference, we're going to be subtracting. So I'm going to be doing 7.75, and I'm going to subtract it from 7.5. So this is my race time, and then this is my time without my water break. Okay, and my race time does have my water break. When I subtract these two, I get 0.25. So how many minutes does Rachel take per kilometer for a water break? She takes 0.25 minutes. So that is how long it takes her for her water break. Our next question goes back to Becca and her ride from the airport to her house. The question is asking us which equation represents the cost of her ride based on the number of miles, m. So if you think back, this might look a little bit foreign just because it's an equation and we haven't yet done equations. We're going to be working with all different kinds of equations and how to set them up in the next unit. So I'm going to kind of explain the breakdown of how this goes. Your total always goes on one side of your equal sign by itself. Okay, so your total should always be alone and it should be separated by an equal sign. My total here that Becca paid was $9. So see how there's $9 on this side separated by my equal sign and there's nothing else over there? These are all good. So all these answers are still in play. The next is this right here. Anytime you see something that has the word per is a word that tells you whatever number is next to that, that's what your variable gets attached to. So here it says 0.5 per mile. This per is telling me I need to take that 0.5 and attach my variable to it. Okay, so when I'm looking through here, this variable here isn't attached to anything, so that can't work. This variable here is not attached to 0.25 or 0.5, so that can't work. This variable here has a 4 attached to it. Nope. This bottom one here, see how I have this 0.5m. This is what I'm looking for. So D is going to be your correct answer. With this 0.5, this m represents that per mile. I'm adding in how much I have to pay just to take their ride share. And then that's going to equal my total, which is how much I spent. And again, we're going to be working with equations much more and how to set up problems like this in the next unit, so in Unit 2. All right, and now we have to set up a equation for Rachel. Okay, she completes her race in 38.75 minutes. That's the total time it took her. So if I look over here, all of these have the total by itself, so these are all good. Let's look at our next part, which is going to be determining the per. Let's see. This one here is actually going to look a little bit different than the one we just did. And the reason why is because we have to kind of factor in her water break. And her water break is, so what the race does is it's going to break it down per kilometer. Okay, so for every 1 kilometer, she runs she can run it in 7.5 miles plus her water break, which here they're letting it be represented by T. So for every 1 kilometer, she runs the 7.5. That's how long it takes her in minutes. And then she also has to take her water break, which is why we have this plus sign here, because we're adding that together to give us the total time. Now, if I look back up here, it's a 5-kilometer race, right? So I'm going to do this step here 5 times. Okay. And one way we can represent that is kind of like a distribution problem, where I know I'm going to do this 5 times. And I'm going to have this 7.5, that's how long it takes her to run her kilometer, plus her water time for each kilometer that she runs. So this right here represents her water break. Okay, so B is going to be our correct answer here. I have 5 times the 7.5 plus T, and that's going to equal how long it takes her to run her race. So again, this one looks a little bit different. And we're going to be working with problems like this much more in Unit 2. All right, that is the last problem for Lesson 4. If you have any questions, please let me know.